Hello, everybody, and welcome back to another episode of The Routing Loop. Just to kind of remind folks, The Routing Loop is here as a show. We are now on Twitch as well as YouTube and I believe LinkedIn. And we're dedicated to show customers, builders, folks how to use and build with AWS networking constructs and AWS networking stuff, right? Hey, Ken, nice to see you again. So today I'm joined by Paul Kelsey. Paul, why don't you tell us a little bit about who you are, what you do, like how long you've been in AWS? So why is it worth listening to you?
Why is it worth listening? Yeah, thank you very much for the intro. Paul Kelsey. I'm a senior solutions architect at AWS. I've been here for 5 years and 4 months, and sometimes people count the days, but I'm not one of those. But 5 years and 4 months. Got several other years in the industry previous to that, and one of those I dealt a lot with some of competitors' content delivery networks. And so when our CloudFront team says, hey, we need to find these people that have areas of depth in content delivery, then I signed up to be an area of depth owner of the CloudFront. So we've got our edge services that run in our points of presence. So that would be CloudFront, web application firewall, Shield, all of those things that run in our POPs. We term those as our edge services. So I'm a member of the TFC. I'm a core member, and I presented at reInvent for the past couple of years on several topics on content delivery.
So I'm just going to take a wild guess here that we're going to be talking about content delivery today.
You got it. We're going to talk about content delivery. We're going to talk about kind of a subset of what you can do in CloudFront, which is where are the things that I can plug into and execute code. So actually running compute at the edge is really what we're going to focus on today, even though CloudFront does a lot more than just that. We're going to focus on. Can you do me a favor?
Let's do a favor for myself and for everyone who's watching. Can you just give us the rundown of CloudFront and just some of the differentiators from our competitors, just to say like why CloudFront, this is what it does, and then we can get into these features of using CloudFront for compute.
Yeah, absolutely. And so several folks likely already know about running in AWS. They run EC2 instances, they run load balancers, they run their applications, or they have S3 buckets for object storage. Right. So those are things that we term in region type of resources in AWS. And so those are great, and those can operate just either as a standalone type of thing. But if you're looking to improve performance, improve security, if you've got some internet facing type of applications, sometimes there are things and implications to putting that on the internet, like denial of service attacks or latency because you're a far way away from one of where you're hosting your regions. So that's where the introduction of CloudFront as a content delivery network can be inserted into your architecture. And now your entry point is now at that content delivery network, that CloudFront. And then CloudFront as a native AWS service can tie back into the various resources that you've got in region. And it just helps improve lots of different aspects of your architecture. So mostly around, people think about it from a performance perspective or a reduction of latency, because we run in what we call points of presence or POPs, and more than our 32 regions or so, right? We've got over 800 points of presence that CloudFront can operate in, and they host the cached content at those various locations. So reducing that last mile to the end customers is really good for performance, reduction of latency, and then we can insert some other things like web application firewall along with CloudFront to improve the security.
Yeah, and don't forget, folks, that those points of presence that Paul had mentioned, the reason why that's so significant is the AWS backbone is brought to those points of presence. And remember, we've talked about it in the past. We don't do any leasing of our backbone from other providers. It's all our fiber. It's all our stuff. So when Paul is mentioning getting rid of that last mile, that internet weather that could be variable in terms of response and timing, CloudFront gets your customers closer to the backbone, which then gets you closer to performant access to your workloads. So that's
a fantastic point, especially relevant for not just cached content, but just getting onto that super fast network for dynamic calls like APIs.
Yeah, exactly. And then also, let's not sleep on the fact that CloudFront also offers reduced pricing for data going out of the cloud, right? So as AWS, we don't charge for data coming in, we charge for data going out. But if you're a CloudFront user, that's reduced as well. And I know for certain types of business, that's a pretty big deal.
Absolutely.
All right. So what do you got to show for us? You want me to bring up your slides? You want to get rolling on that?
Yeah, let's do that. What I thought we'd do is for anybody that wasn't able to join reInvent, those are one set. But if you weren't able to join, myself and David Brown did a chalk talk. And so if you've not been to reInvent, a chalk talk is a little bit more of an interactive type of session where I'm just not going to throw a bunch of slides up at you, but let's talk about specific use cases that you've got and related to edge compute in Amazon CloudFront. And so we did this talk, and we probably have about 10 slides that we can refer to, but the preference would be if we've got some use cases, if people are already comfortable with things like Lambda at edge. And if you don't, that's okay. We'll talk about those, or CloudFront functions. If you've got already some use cases and questions, we can talk about those in this format. But we'll start off with the slides. And sure. That'll help us lay some foundations for those of you people that aren't comfortable with the terms or are new to CloudFront and edge compute. The first thing that we point out, and if you want to go to I've got the next slide up here where we'll talk about the agenda. We don't have to cover all this, but we had some feedback on just what edge is. So that's where we've got an asterisk on Amazon CloudFront as far as edge compute, because edge could mean hybrid, where you've got things running in your local data centers, and that's somehow connected into AWS. So we're not talking about that as edge. What we're talking about, at least for today, is edge compute, as far as that running in the points of presence with CloudFront in those POPs. So
the first thing your data hits or your request hits before it gets into your workload. Absolutely. And it's distance from the region too. So remember that as well. So just to kind of paint that mental picture of edge, right? Yep. This is still connected to your workloads, but it's not your workloads. It's on the edge where the traffic first comes in.
Absolutely right. Yep. And it's completely managed. You have some control over how long things you want to stay in the cache. You have control over invalidating things in the cache. But for the most part, it's a managed service that just it's hands off, and it just improves your security and the latency and things like that.
And here's one question I usually get about CloudFront that usually gets me me on edge. So you can only do cacheable content in CloudFront?
No, that's not true. Oh,
I know. I've always been asked that, and it's like one of those.
No, it's very valid. And so the example I gave just before was like if you've got some large video files, it's fantastic for that. But what if you're doing something like an API call to find out, to place an order? That's not something you would want to have cached, right? But exactly. CloudFront can help you get to that closest point, that last mile, and then accelerate that. And so it acts as that route into the AWS network and improves the security of those calls. Now, the interesting thing about even dynamic API calls, and I'll go into the weeds around, my own thoughts on cacheable content. Sure, static objects, image files in S3, absolutely. Some API calls, although you might think of them are dynamic, I still think those could be cached for a few seconds. Right? A 10-second window of the top 100 products on my website is absolutely valid for a 10-second, and that can help offload, those API calls directly accessing your resources at the back end. So it's a great way of doing it, even for somewhat dynamic content.
What about authorization and authentication at the edge?
There's several things, and it's a great point. One of the things that we can do at the edge, and we'll talk more about this as far as our options. What are in our toolboxes, and maybe it's a good point to go see what tools can we use at the edge, and that might help answer that, Jamie. So when it comes to the tools at the edge, I mentioned CloudFront mostly from a managed per service perspective. There's a lot of native functionality built into it, like geo restrictions, like custom error pages. All of these things are kind of built into it and things that you can configure. But what about the areas where I need to do some custom compute or custom things? And so that's what we'll focus on today as far as the tools. And I broke this down into two different categories, and we'll see different characteristics of each. So the first one, been around for quite a while. It's called Lambda at Edge. And so if you're familiar with Lambda functions at all, these are serverless functions that just run within an AWS region. So think of it as you bring a Python code and it serverlessly can react to requests, and you can have multiple concurrent instances of these Lambdas. We took that idea of Lambda running in the region and we said, well, hey, wouldn't it be great if at the edge we could refer to some of those functions and do something complex. And so that's the nice thing about Lambda functions is, right, it's almost the sky the limit. If you can imagine it, if you can code it, then it's possible to implement it on a Lambda function.
Nice.
Yeah. So some of the characteristics, though, and this is where the other compute type will differentiate, and so we'll see that in a minute, is the scale of these Lambda at edge, when you can associate these Lambda at edge with your CloudFront, and for certain types of requests, you would then invoke this random Lambda function that does whatever it is you want it to do. So a couple of the characteristics, the scale, it's thousands of requests per minute. Right, the languages are Node and Python; those are the ones that are supported. And so it's a subset of the full Lambda functionality with some of these restrictions, including the latency. Right, if you're thinking about an interactive website, you wouldn't want anything more than a 30-second type of latency, but a Lambda at edge can run for up to 30 seconds.
Nice. We actually have
yeah.
one question here that I think is actually relevant that you're getting to.
Okay.
Can you explain the difference between CloudFront functions and Lambda at edge?
I think somebody must have sat in on this presentation.
I know.
The very next compute type, if I go forward just a little bit, and I will complete out, I do differentiate the Lambda at edge versus CloudFront functions.
Perfect.
So let's stay up with the characteristics of Lambda at edge first, because the complexity of this Lambda at edge, it's really meant for medium to high, because you're not running too many of these, right? If you think about a super high scale website, this thousands of requests per second is not really something that you're going to want to have. A lot of our websites handle millions of requests per second.
Right.
So that might not be a good fit here. But the other part to this is Lambda at edge has access to certain things like the file system or other AWS services, like if it wants to talk to a DynamoDB table. These are things that you can do in a Lambda at edge, whereas you'll see you won't be able to do this with a CloudFront function.
Now, before we get to the CloudFront function explanations and you do the comparison, I got one question on Lambda at edge.
Sure.
With Lambdas, one of the things that we've always heard about is cold start, right? We got to wait for that Lambda to warm up. How does that happen? What do we do with Lambda at edge on CloudFront? Is that a thing? Is that something we have to worry about?
Well, so there's the way under the hood that Lambda at edge runs. I've already described the difference between a POP and a region. So our regional resources like our ALBs and our EC2 instances. Lambda at edge actually runs within one of those regions where we have something called a regional edge cache. So from that POP, it's got to make a hop to whatever region that regional edge cache is in. And so it still would be subject, depending on how frequently that Lambda is invoked.
Right.
It still would operate very much like a traditional Lambda. Now,
so a good candidate would be something that is invoked a lot. That way you don't have to ever really worry about that cold start.
That's correct. And there's other ways in Lambda that you can get around that cold start.
Cool. Okay. Yeah, I just want to make sure that we're honestly saying when we say Lambda at edge, it's Lambda.
It's Lambda.
Not like, it's not something goofy or special. We're not just rebranding another thing. It's the same thing.
It's the same thing. And I mean, it's a good thing you said that, because if you think about concurrency limits, that's a lot of times you'll have to deal with noisy neighbors, or how many actual Lambda invocations are done across my account, right? There are limits that are at the Lambda, and the Lambda at edge that works with CloudFront is subject to those same limits. So that's some consideration. If you've got thousands of requests coming in from a Lambda at edge, that can affect your other Lambda functions.
That's a good point. Very good point.
So a couple other things, more recent features is what we focused on a little bit for the Chalk Talk. Things like the advanced logging control. And for each of those, we'll put up a couple of blog posts that talk about when they were announced. Obviously, we're a few months past reInvent, so we've got a whole new slew of announcements. So we won't cover those. But let me get into, if there are other questions on Lambda at edge specifically, the next part will be just to see how CloudFront functions look a little different.
Okay. Yeah, I don't see anything in the chat just yet. So let's do that comparison for TechFuel.
Cool. All right. CloudFront functions. Let me first say that look at this first item, which is the scale of this. So millions of requests per second. These are meant to be much more lighter weight. You see complexity of low, right? You see latency of sub-milliseconds. So all of a sudden, there's quite a difference in the characteristics between these two options. And with that comes some considerations on what exactly you're trying to do, right? If you're trying to do some kind of encryption or decryption, right? Sometimes that can be done more appropriately in a Lambda at Edge versus in a CloudFront function. You'll see that the language is limited to just JavaScript and TypeScript for that. And there are differences in sizes as well. Of a Lambda function it can be much larger than a CloudFront function.
Okay.
So I'm purposely avoiding the plug points, and nobody's asked me about that yet. Surprised, Jamie, you didn't ask me about that.
I'm on that. I'll ask it. All right. When do I use Lambda at Edge?
I was going to say ask it.
When do I use one versus the other?
Okay, yeah, because I've got a whole slide that talks about where we plug in, but it is different, right? You have 4 for Lambda at Edge, and you only have 2 for CloudFront functions, and we'll see why that makes sense in just a few more minutes.
Sure.
So the features of the CloudFront functions is these cannot have network access, right? They run in those points of presence, so much different than a Lambda at Edge where it's in the regional edge cache. It's CloudFront functions are going to run in our 800 plus points of presence right alongside WAF, right alongside the actual cached content that you've got. And so for that reason, and that timeline, that latency of it has to be executed in under 2 milliseconds, right? Those are things that you're not going to necessarily do very much complex things, and you sure as heck aren't going to go call a DynamoDB table.
That's true.
Yeah.
That's true.
So, but that came with some limitations as far as, well, how useful are they? And so the things that CloudFront functions are really good at is any kind of header manipulation, URI manipulation, things that you can do very, very quickly, just related to the payload coming in or the payload going out. And we'll get to that in a second. So there are some certain use cases, and we'll talk about several of those as examples and even quiz the team on, after they hear the differences, which they would use. So, but for a while, that network limitation, that being able to get to any kind of data, like that's not ephemeral data or part of the request response flow, that posed a challenge. So the answer to that was something called a key value store. And you see that called out as one of the features only available to CloudFront functions, but it is something that you can now have an arbitrary set of keys that's managed in a central location and then is distributed to all those points of presence. And then all of a sudden, you have a little bit of an idea of being able to maintain some type of data set that's available to all the CloudFront functions.
That's cool. That's cool. I remember, just back working with a customer, they had used CloudFront functions, especially with the header manipulation, to actually help them bring a legacy system that they had from on-prem into the cloud, which needed a specific header type and a specific way to be called. So they actually used CloudFront functions to basically transpose the requests from the internet over to this backend system until they can, modernize and get things going. So
yeah, absolutely. That's
very
that's one of thousands of use cases that you can think of for this.
Yeah, and then it was performant. They were really surprised. It was almost to the point. I remember we were laughing in a conversation where they're like, "We could just leave it like this," and we're like, "No,
stop the migration. Let's just keep it like this.
Yeah, let's just do this." It's like, no, don't. But yeah, it is pretty quick, CloudFront functions, and then of course Lambda at Edge. We've got tons of examples for that. I know we can go into later.
Yeah, absolutely. Yeah, we've got many examples of Lambda at Edge, many examples of CloudFront functions, and the thing is, the interesting thing is that you can do a lot of use cases. You can say, well, I can do that for both, right? If I'm trying to do XYZ, it could be both. And then you have to take into consideration where in the flow you want it to execute. And that sometimes drives whether you do Lambda at Edge or CloudFront functions. But a lot of things you can do using both of these technologies.
I used to say back in the day when I was doing a lot of Unix, I used to do a lot of Linux and Solaris and whatnot. If you can't figure out how to do one thing in 6 different ways, you don't know Unix. Now it's the same way for architecting in the cloud. If you can't architect something at least 6 different ways using cloud, features and functions, you don't know how to architect for the cloud.
Darn right. Open up the bedrock and ask Claude, right?
Yeah, exactly. Claude, please help me.
Right. Yeah. The last thing on this one that we covered was recently we added some additional capabilities, both in CloudFront functions and Lambda at Edge, to allow for origin modification. So basically some helper methods within your code that makes it real easy to change where the request is going very dynamically based on, could be arbitrary things. It could be good for A/B testing, but origin modification is something that was recently added to some of the capabilities of both Lambda and CloudFront functions.
Yeah, we have Dominic has just basically made a comment. He says, when can we run Lambda durable functions at edge? He says, I know, Robert. But the thing is just to kind of bring that home is that, this is becoming more and more of a norm, for AWS users with CloudFront, as opposed to an exception, right? Using the Lambda at edge. So of course there's a lot of features. So what I'm going to say about this is, as Dominic has mentioned, we can't talk about roadmap, but what you guys can do is you can put in the chat, hey, I would like this function. I would like this feature for Lambda at edge. And myself and Paul will be more than happy to bring it back to the service team, because customer feedback is most important.
Absolutely. Yep. And when I was in Las Vegas for the reInvent, I was partnered up with David, who you may have even seen on the title screen, and he is the actual product owner for CloudFront. So I've got a short circuit way in. If it shows up in the chat, it'll go directly to him right after this.
Yeah, it's sad that we had to miss where you couldn't show up today, but yeah, we'll bring him the message.
Yep. Cool. Here's the plug points. So this is the one item that Jamie, you asked me about, that I said ask me about, and we'll skip over it. So if we think about inserting CloudFront into the middle of our architect, and hopefully, I don't know, Jamie, can you see my mouse moving in the middle of this?
Yes.
Okay.
I see your mouse.
So when we talk about inserting CloudFront into your architecture, a lot of traditional architectures here on this right-hand side, that's your ALBs, that's your EC2s, right? We term that as your origin when we've got add CloudFront inserted. So this may be your endpoint now. This may be your entry point. This is running in region. When you insert CloudFront into the mix, right, you have this intermediate proxy layer that is going to help you out with your caching of content. This path here from CloudFront to origin server, we already mentioned, over the AWS private backbone that's monitored. So that's already helping with some of the latency. But think about, because we've added this additional component, there's 4 areas. All the way on the left-hand side, we've got our end users, and those could be in California, they could be in US, they could be in Australia. But the 4 areas that we talk about as far as plug points are on the viewer, on the incoming request into CloudFront. And then CloudFront can do some processing, and it's possible that it's not a cache hit. It's possible that it's possible that the CloudFront immediately responds back to that with cache content, or it could be that CloudFront says, hey, I've got a geo restriction, so you don't get to go any further. So lots of different reasons for this to just be very short-circuited request response, but that's on the viewer side. And that's one of those optimization paths is if you're wanting to have a high cache hit ratio, a lot of times that offloads a lot of resources that are consumed by your origin. So that's a cost of ownership kind of thing. But so those are 2 areas that every time a request comes in, those 2 plug points get accessed or get exercised.
Mm-hmm.
Now, if CloudFront doesn't have it in a cache, or if it's a dynamic request that isn't cacheable, then we will make our origin request. Then the origin server will respond however it wants to respond, and then you get an origin response. So the plug points, we have 4 altogether for both of these compute types. Lambda at Edge can execute at all 4 of these. Okay. And by nature of that, right, you could be invoking 4 different Lambdas if you had it. We wouldn't necessarily recommend that because there's some appropriate things you can do, but it's really good for doing things like optimizing that cache hit ratio, is making sure as many requests come into CloudFront as possible, get that cache hit if it's possible.
Right. Keep that alive.
Yeah, keep that alive. So the CloudFront functions, think about the nature of those. Those are much quicker. Those are much more lighter weight. Those are much simpler. You can only put a CloudFront function on the viewer request or the viewer response.
Ooh.
So a request comes in, my CloudFront function can do things like update the headers. To Jamie, your point, it can update the cache key so that it actually lines up with something that might already be in the cache, even though the normal CloudFront processing wouldn't have lined up the cache key. So it can do lots of different things, and then potentially, optimize and enhance the response flow. So request, very lightweight things. It can do things like check a SIGV4 type of signature coming in. So very lightweight cryptographic stuff, just HMAC stuff, but it can actually do that processing within that CloudFront request before CloudFront proper handles it. And then the viewer response, if you had a whole bunch of CORS headers, right? That bit me back in the day where your CORS headers needed to be updated because it's non-prod, right? That's something you really easily, either in the viewer response, and I think that's actually built into CloudFront natively now. But you know, for a long time it used to be you had to do that at a Lambda at edge, and now it's much more lighter weight and it's very appropriate for that viewer response.
Okay.
Cool. Hopefully that makes sense. Those differences in characteristics, feature functionality, what you can do in a Lambda at edge and what you can't do in a CloudFront function. A lot of times that steers us, which is the right way. And then obviously the scale of it, millions of requests per second, you're not doing Lambda at edge.
Cool.
All right. CloudFront, key value store. There's a little bit more details on this. It's a newer add-on to it. We may have already covered on the capabilities of this, but like I mentioned, centrally managed, a place for some types of key value store. This we've seen customers, and we actually have a customer reference that basically had a list of tenants in a multi-tenant application, and they were able to line up which tenant was served by which region. And so, right, if that wasn't persisted somewhere, right, that might have to be a Lambda at edge to check a DynamoDB table or or an S3 table. But with this key value store, if I lined up tenant A goes to US East 1, tenant 3 goes to US West, right, having that as persisted as a key value store, propagated, then allows the CloudFront function to be able to route to the appropriate origin within that region. So that was a great example where, let's see, I'll even skip ahead because we'll come back to that. Atlassian did that. And up until they had that capability of key value store and CloudFront functions, right, they had to route everybody, and then their back end did the logic. So there were a lot of inter-region communications, and they were able to save that by short-circuiting that with CloudFront functions.
So much slower in the old way versus using CloudFront.
It was much slower in the old way. Yes, absolutely.
Yeah,
Not
you
only
have to keep
save money,
that.
It was faster. It was a better experience for their end users. Yep.
That's two of the tenets of well-architected.
Yeah.
So the other thing too is key value store in CloudFront is one of the things I remember I had a conversation. It's not DynamoDB.
It is not correct.
It is, you know, if you need DynamoDB, you still need DynamoDB. I've seen some customers who are like, well, we can do these things. And it's like, you could do some of those things. It's lightweight. It's a place to hold information and be able to match one thing with another key value, right?
Yes.
Whereas I know DynamoDB is a key value database, but there's a lot more logic on it. There's a lot more compute. There's a lot more things that it does. So please don't think that we just took DynamoDB and put it in CloudFront.
100%. Conceptually, yes, shrunk down quite a bit because remember, CloudFront functions, they're going to access it really, really quick. So there is a 5 megabyte limit to your key value store.
That's a good point too. There's the size limit. It's always a good idea just to put in pointers or something as small as possible. Please don't put key value images.
Right.
Things like that.
Yep. Agree on it.
I've seen that attempt too. That was like, hey, I put all these images in this key value store, and it's not really, it's like, hey.
No images, please. Yeah.
Yeah, please don't do that.
Cool. Any other questions that we've got coming through? No? All good?
We're pretty good. Yeah.
Nice. All right. So when we did this talk, I was telling Jamie before we started, I brought along with me a little jar of jelly beans. And when you're in person and everybody's coming in, filtering in, I passed around their jar of jelly beans, and it was just for this slide. And so this is one of those things where if you've not played the jelly bean game, and hopefully everybody here has, whoever got closest to the number of jelly beans in the jar won the jelly beans. Right. Nice. And so for this case, we played that game. And so the first kind of jelly bean question is, how many CloudFront functions have we had over the past year? And again, this goes back to December of 2025, but it was a year around. Anybody want to put a guess?
Anybody out there
across
watching?
All of CloudFront, across all our customers, how many times we invoke a CloudFront function?
We'll give it a couple of seconds, but we'll probably have to give the answers, and we'll just see if anybody guesses right. Because there's always there's 1B.
Yeah, it actually takes away from it because we actually don't have a jar of jelly beans for you to keep. So
1 billion a day is
1 billion a day. So what would that be? 365 billion?
365 billion. We also have 10,000, or what is this?
I can't count that number of zeros.
5, 6, 7, 8, 9, 10, 11, 12. Okay, so 1 billion. Yeah, so a lot of people seem to think it's that, but it seems like
it's actually 370 trillion.
Nice.
So that's not meant to be braggadocious by any means, but it's just meant to show kind of the value of being able to do these quick things, right? This isn't super complex. It can't be super complex, but it can be very, very flexible and useful. And so that's what we're showing as far as across the board. Now, the second one was since we introduced Key Value Store, how many invocations of Key Value Store reads have we got?
All right, so folks, put in what you think of how many times Key Value Stores have been read. And while they're putting in their guesses, I have to say the one thing that's important and impressive, right, especially in IT, is that generally when we look at a number like 370 trillion function invocations in the past year, it could lead people to believe that we're running this at lock. Like, the servers have like tiers coming down the racks and these things are super hot. But that's just not the case. We have more capacity, right? This is what we're running comfortably a year.
Yep.
So I just want to make sure that that's really put out there. We're not, the gas pedal is not all the way down.
Yep.
All right. So for our guesses, Key Value Stores, we've got 600 trillion by hirings. See, now you've got people thinking a little.
Now they're overshooting a little bit.
947 trillion, and then of course, Erie, you get the prize for gazillions because I like
gazillions. All right, it's still an impressive number, but if you remember, right, the Key Value Store is associated with our CloudFront invocations, so I think it has to be smaller. Yes. But when I first saw these numbers, the interesting thing was, every single CloudFront function is doing a Key Value Store read, right? I mean, you're short 102 trillion, but the majority of these seem like they're running at, what is it, 72%? I think we captured that in the math. So I was thinking that everybody's using Key Value Store. And when I posed this question to David, he said, actually, no. It's actually only about 15% of the Key Value Store reads of the CloudFront functions are using the Key Value Store reads. So, I mean, that means that the people that are using it have found value and they had a requirement for it, but that percentage seemed like it was a little bit off. And I just thought that was an interesting anecdote on, the use case for Key Value Store. And just though that people are seeing value for it, just like Atlassian, and that means that those are doing multiple reads of that Key Value Store per invocation.
But the major point is that even though these numbers are kind of close, the Key Value Store read number is not because of the CloudFront functions. There are some that are because of the functions, because CloudFront functions work with the Key Value Store, 100%. But the majority is on its own. It kind of stands on its own.
Yeah, absolutely. Yep.
Cool.
All right. Well, let me go back because I've got a couple things. Okay. Nobody look.
Yeah, we didn't see it.
Nobody said don't pay attention to the man behind the green curtain.
We got one question actually here by Tech Fuel. Before we move on, is Key Value Store part of CloudFront Function Service or separate?
So Key Value Store is a part of CloudFront function. CloudFront service. CloudFront Functions is also. So when you get into the CloudFront console, you'll see Key Value Store as a separate section in the console, and then you'll see CloudFront Functions as its own. Now you associate those functions with the Key Value Store. So you manage them separately because it's possible, right, that you can have a Key Value Store used by multiple functions. And so that's why they're not tied one to one. And that's the other interesting. That was the other differentiator on CloudFront Function. When you code up a CloudFront function or use some of our samples to start out with, that's done in the CloudFront console itself. It's not in Lambda like our other way, our CloudFront Lambda Edge way.
Got it. So one thing to think about is like you could have an instance where you got traffic coming in, a request comes in, a CloudFront function is invoked, and it makes a change based on what comes in to the Key Value Store. And then another request comes in and reads from the Key Value Store. Now it's been changed because of whatever happened before. So this could be, think of it as a persistent and yet dynamic system that CloudFront functions and Key Value Store, as well as Lambda at Edge, are three separate things that can use each other, as opposed to three things that have to be used together.
100%. Agree. Cool. So here's the part that we polled the audience as well, and if we want to do that here, we can, or I can just talk through it. So two options that you've got. So use cases for edge compute. That was, practical applications. That's the title of our Chalk Talk. So to start this off, barring any customer use cases, we said, well, if we wanted to do some kind of advanced request routing, right? That could be geographically based or canary based, percentage deployments. Which one, based on the characteristics that we've talked through already, which one would be more CloudFront function, or which one would be Lambda at Edge? So the advanced request routing, does everybody think it's Lambda at Edge?
We'll give you guys 5 seconds.
Okay,
to figure out.
I've always heard, Jamie, have you heard this? If you do a 7-second silence, that's long enough to be awkward, yes, and good enough to give people a chance to respond.
Yeah, no, it makes sense. And sometimes too, depending on the different platforms, it could be a little bit laggy. But
yeah, absolutely.
So we've got CloudFront 2, CF2.
That's CloudFront functions. That's kind of an acronym.
Yeah. And then we've got off by Rolex CMC, which I'm not too sure on off. But why don't you give us the
Here, we color coded that CloudFront functions, and remember that was very lightweight. If you wanted to do a 10% type of routing between A and B, that's pretty easy to just calculate that, and then but it would be random, right? Yeah. You can also do things if you've got session stickiness, if you've got a session ID header, right? That's something that you could maintain that.
Yeah, no, it makes it safe harbor, a lot of that stuff too. Yeah. Like if you're restricting from certain areas, a lot of our folks in Europe with medical data have this restriction. So this would certainly help for that.
Yep. Okay. And kind of we touched on it, A/B testing and feature flags. This one is a little bit tricky because I added this feature flags in here. And so if we talk through out loud, would that be CloudFront function or would that be a Lambda at Edge?
So give me an example of this while you're getting some answers.
So I log in and I'm in an organization that has a SaaS-based product, and I'm a tester for that organization, and I want to access the test environment, but I'm going through the same CloudFront distribution.
Okay. Anybody have a guess? All right, let them know what it is.
All right, so this is one of those. Yeah, hybrid. It more depends, and so unfortunately, lots of these could be this hybrid like this. If it's
a hybrid feature. Yeah, not hybrid. I know it's very dangerous lexicon on the routing loop.
Yep. So anyway, so A/B testing could be done by both. When I think about a feature flag, that might be something that is it turned on or off, and that's done at a central location. That could be key value store if you've got a list of those toggles, if you will. But it might be in DynamoDB. In that case, you have to do something in Lambda at Edge. So ideally, right, that would be moved into a CloudFront function using key value store. But this is where, depending on the complexity of this, that's where it goes one way or the other.
Yeah, so basically, because a lot of times we always get asked, right, as solutions architects, what's the best path? And this is one of those ones where it depends, right? Like you said, if you can keep your decision making in a key value store table, definitely put it on the edge because it's quicker. But if you are getting into more complexity, don't try to force the key value store. CloudFront functions. I'm saying key value store. Don't force CloudFront functions to do more than it should. Right? Definitely know when to go to Lambda at Edge, and of course, contact your account team and your solutions architect or your TAMs. They'll help you out.
100%. Yep. All right, authorization. That's one that's commonly used. So that's more of a CloudFront function. You can do some simplified type of decryption for HMAC based. And this is something that we focused on. This is not for the RSA type of dual encryption, right? So that's still reserved for either Lambda at Edge or even at your end use case. But there are some use cases, and we've got a sample in our GitHub samples that shows how you can do a decryption of a certain key, and you can verify the hash. And by doing that verification of the hash, all of a sudden that shared key is something that you validated, and that could be in a level of authorization. And that's actually what we use for our SigV4 too.
Yeah, that makes sense. Rolex IM is on a roll with his guesses here. He's doing pretty well.
Oh yeah, cool. All right, maybe get him a jar of jelly beans at the end of this.
Yeah, we'll send a jar of jelly beans. But yeah, so access authorization. Give us an example.
All right, so you've got some type of shared key that you've got this cache for, and I mean the example of that we use for our identity management is a good one that could be implemented very similarly in a CloudFront function. So right when you send in your access ID and your secret, you're not actually sending your secret, right? You're using the secret to generate a hash of the access ID, and then by nature of it, if we do a decryption of it, it has to be, right? We're using that shared secret, which is your key. So you can implement something much like that on your own.
Very cool. You can keep it a bit more obfuscated.
Yeah, exactly. All right. Reading and writing user profile information.
What do folks think about this one? And give us an example so that they give them a little time to guess.
Let's say preferences on the products that I most like to see. If I took an Amazon.com example.
Yeah. So you go into like some shopping site and a little side panel pops up and it fills out a lot of the things that you normally shop for.
Yep.
We've got Lambda at Edge is the number one guess so far.
Ding, ding,
Lambda
ding.
Edge.
Yes. Very nice.
There you go.
And to dive into that a little bit more, right? Some people might say, well, CloudFront function key value store. Remember, right, at scale, that's not something that you're going to be doing, right? The rights to add to the key value store are not done on a per request basis, right? They are managed centrally and then distributed out. So that's not going to be something that I update my profile and that somehow updates the key value store. So that's where that becomes, okay, that's more of a DynamoDB. That's where Lambda at Edge can say, okay, let's write this off to the table.
It's pretty funny because TechFuel is like Lambda at Edge, DynamoDB, and then Global DynamoDB. Yeah, very good.
And then I forgot I actually called it they're stored in DynamoDB. So that was a big hint, I think.
Yeah, I think that was a bit of a big hint, but still, very cool.
Yeah. All right, and how about our single page applications? You can do a root URL, but a lot of these things have URI paths that assume a kicker file underneath there. And that's something that's just very easily done. When I do a /account and it actually needs to render the index.html, it doesn't show up in the URI, right? That's something that very easily can be handled within a CloudFront function so that you get that kicker file.
Yeah, and I just want to also point out from what you were talking about too, using SigV4. Just for folks who don't know what that is, SigV4 is the Amazon signature. It's basically a process that we use to sign things. And the reason why we know it's very secure is because it's based on a lot of the constructs that we make. So it'll use things like timestamps. It'll use things like IDs of VPC IDs and things like that. So there's a whole page on SigV4 on why it's good. We also use it in other things such as VPC Lattice, right, as a signing thing. We consider it one of the more stronger signatories in AWS just because of the fact that you cannot insert or spoof any of those pieces because it looks at the environment and the platform that it sits on to help generate those keys. So I just wanted to make sure that, why are we saying SigV4 is a big deal? It is a big deal because realistically, it's one of those things that helps secure even, logging into AWS.
Yeah, agree.
Yeah, TechFuel's like, I love IAM SigV4 much better than MTLS. Yeah, especially if you're bringing that in. Again, I'm going to bring up the VPC Lattice example as well. If you're using that to sign your services and stuff, it really is a thing of beauty. And there's a lot of cool things you can do with it with your code. But back to CloudFront. Yeah. We could always go off on multiple tangents when we talk about networking and edge networking.
Darn right. So let's see, we touched about these, and so we're not going to throw these numbers up again. Here is a nice QR code. So a lot of these things, I've mentioned some AWS samples, right? Building up high availability architectures, having multiple origins, CloudFront functions, being able to display. So lots of things around the edge, whether it's computing or design and architectures, we always throw up a QR code that points to our, that very first one you can see, HTTP redirects and management. That's one, and then the edge functions. Several of these just take you to solutions and ways to implement them, get you started up and running quick.
Nice.
All right, so that's all I presented. So I know that we've got a slide or two, but do we want to take some input from the customers and see if there's any questions?
Sure, sure. But I also want to, whilst we're waiting for some questions to come in, because again, guys, folks, as you know, ask as many questions as you want. You have been doing a good job of asking those questions. But one thing that I also like to point out that you said was a feature of CloudFront. And I know it's not directly a functions feature, but WAF, Web Application Firewall, right? I work a lot with app networking things, obviously. A lot of these folks know me to do a lot of things with like Lattice and ELBs, API Gateway, right? And all those API Gateway and ALB also have WAF. So one of the things that I usually get asked is like, where's the best place?
Where do we put WAF? Yeah.
Yeah, where do we put it? So I'm going to pose that to you. I have my answers and my thoughts, and I know there's differences. So I wanted to have you give that thought out too, because if you screw this up,
you'll hold me accountable.
No, I'm just saying not you, but like if someone screws up where to place WAF and how they configure their WAF, they could undo all the performance gains that they've gotten by enabling CloudFront in front of ALB. So go ahead and give us.
Oh yeah, absolutely. And one of the things, and you can really mess yourself up by not using WAF, especially if you're internet facing. Exactly. Right. So WAF, Web Application Firewall, that ties in very nicely with, as you mentioned, ALBs, API gateways, and then also with CloudFront. So if you think about your security in layers, right, you've inserted CloudFront into this. As soon as you can detect either a denial of service type of attack or a rate-based control or an application vulnerability like a SQL injection, the sooner you can catch that on the outer perimeter, the better you are. So there's a couple strong reasons to incorporate WAF, Web Application Firewall, with CloudFront. And there's actually one-click enablements now. So we've made it a lot simpler to see what kind of attacks are coming in. And one click saying, oh, look, you're getting a lot of SQL injection attempts. Do you want to enable this WAF rule? And the nice thing about Web Application Firewall, it's not an appliance type of thing. So there's no IP address changes. You don't have to route it. It's integrated directly with CloudFront. CloudFront will get the request. It will check its security controls like your restrictions. It'll check a few of the things. It won't execute our compute. It'll then defer that to WAF to run through its environment views, right? And so that could stop rate controls. Yeah. And then if everything's happy about that, then it'll go and invoke your CloudFront function, all this other good stuff. And then eventually it'll get to your origin if it's so needed to. But the way I like to prescribe this is if CloudFront should have WAF enabled. And in that case, CloudFront should be your only entry point into your application, right? A lot of times I've had customers have an ALB that's public. They say, hey, we need to put CloudFront in here. Okay, let's put CloudFront in there. But they forget to close that entry point from ALB. So they've done a CNAME change and they've done a few things, but somehow people can still get to that ALB. And that's just, you're almost asking for trouble for that, because there's a lot, because of those points of presence, because we're processing it at the edge and not in the region, we've got a large amount of infrastructure that can defer and take away some of that attack traffic, including we can do some smart routing at the CloudFront points of presence that say, hey, we're getting a lot from here. Let's shift the traffic quietly to a whole nother point of presence, isolate all the bad traffic to one, and really get into that. So it's really I encourage you to look at Web Application Firewall, especially public facing. And we have lots of other mechanisms to have that security in layers. So do you need it at the ALB? A lot of times you won't necessarily need that double WAF processing as long as you've got it at that one front door.
The one thing that I would say that would be just a little bit different is if, depending on the way that you set up your environment and your security, there may be instances where you need something internal, like an internal WAF. And if that's the case, if you have a CloudFront sitting in front of an ALB and you have internal requests for an ALB, then we usually say, put your macro rules, all of the ones that will be hit the most at the edge.
Yeah.
And then any micro rules, anything that needs to be further extremely evaluated, put it on your API gateway or put it on your ALB. But absolutely, WAF on CloudFront, if I'm going to pick one or the other, I'm always going to try to put it as far away. Think of it, I always think of WAF as something that will capture like radioactive garbage. And how close do you want to hold that to yourself and your family, or how far do you want to hold it away?
Yeah.
Right. Absolutely. So you put that radioactive garbage on the edge. The other thing too, which is really, really cool that most people can sleep on, you mentioned DDoS. Well, if we have WAF on CloudFront, then we also have Shield Advanced, which will allow us to help you as a managed service to say, hey, we're seeing that you're getting attacked from a known bad address. We can go in and add a WAF rule to immediately block that for you, right? Or if you're getting attacked from something and you need help, right? Because sometimes some of these attacks, especially distributed attacks from like IoT devices, could be very hard to pin down. So you can call up the team in the
Shield response
Shield
team.
Advanced team, and then they'll basically help walk you through like, all right, we can see what kind of traffic's coming through and also what we can block. And then the last thing, again, you've got this single entry point now, right? We're using CloudFront. Maybe we turned off like internet access onto our VPC. So the only thing that can come through is coming through CloudFront, hitting like some sort of an ELB or something like that. And we're really, really happy with that paradigm. But also we want to have a little bit more understanding of how we're getting hit. And because now we're forcing everyone to come through CloudFront, we can also use the WAF with CloudFront for statistics, right? Where am I getting access from the most? What type of content is getting access the most? A lot of these statistics that folks want to know, right? What part of my website is going to be accessed mostly? You can put in things in WAF to capture that data, right?
Agree 100%.
And CloudFront can do it as well. Can you talk a little bit about the logging capabilities and what we can do with the logs with CloudFront? And I know we only have like 9 minutes left, but I also want to make sure that the automation piece has been discussed.
Yeah, so lots of different options, just like all the other AWS services. One of my favorite is if you've got already your security systems, right? You can use Kinesis data stream to point those directly to a Datadog type of situation. You can send them to CloudWatch logs. There's a great set of tools called CloudWatch Log Insights that allow you to just do it's own query language. You can build up dashboards within CloudWatch. A lot of different metrics are coming up, so not just logging, but what's your cache hit ratio is a lot of times what people are interested in, and they want to optimize that. A lot of that bubbles into CloudWatch. That's our built-in observability stuff. And if you're more cost conscious, you can store them directly to S3. Use something like an Athena to do some ad hoc querying post request. So that wouldn't be necessarily a real time. So lots of different options. And I mean, to build back on, CloudFront logging marries very well with the WAF logging. And so there's a whole set of things that you can correlate between them, including Web Application Firewall puts on these labels. So for every type of attack that it sees, right, you can see the attack vectors that are coming in. So that's what we a lot of times will recommend. Turn on your WAF, put it in count mode, and just look at the traffic coming in. Look at those labels, and then you'll know what exactly to block and how to construct the structure rules. So, but they're very tied together as far as observability. Exactly. One thing I was going to say, Jamie, about the Shield Advanced team is actually the threat detection from that actually spawns from our Amazon, so the retail sides, and you can imagine what kind of vectors they see on a daily basis. A lot of the stuff that they learn from that gets folded into Web Application Firewall, Shield, and as well as CloudFront to some degree.
So Rolex has one last question before we go. Would it be okay to say always enable WAF in CloudFront? Or are there any cases where you guys don't recommend WAF in CloudFront?
Public facing, always, yes.
Yeah, I would always say that too. Public facing, definitely turn it on.
And so, and there's also there's that interesting nuance to CloudFront that it is always public facing, right? When you create a distribution, it's advertising those IP addresses. Now, there are things that you can put in there, either in WAF or some IP sets that you can limit that to a certain VPC CIDR. So there's ways that you can kind of turn CloudFront into something that's not as public, but still internal bad actors aren't right.
Yeah, I know. There's usually other ways, hopefully, to detect internal bad actors, and a lot more controls than it is for some anonymous, but let's call them jerks on the internet that want to cause harm, right? So
I would say 95% of the time, let's put on the WAF.
Yeah, let's definitely do that. And so we're at the point of the show where unfortunately we have to conclude. So usually at this time, I always ask the guests, tell us one thing. If you want us to take away one thing from what you've shown us today, what is it and why?
Sorry, Jamie, was that a question to me or was that to the audience?
Yeah, it's a question to you. Yeah. So what do you want us to take away from this presentation you just gave us and why?
Yeah, absolutely. So I would summarize this as saying the sky's the limit. Right? if you've got CloudFront and you've got a need to do some level of customization, we've got some tools, we've got some things that are built in, we've got some things that allow you to expand and code yourself. But there should be a way for you to work with your account team with AWS, or be able to accomplish a lot of complex things, or very simple things that you wouldn't have thought of, using our edge tools, the options for edge compute.
Awesome. Well, you heard it from the man himself. Presented it at reInvent. Thank you again for coming on the show. Definitely have to have you back. Talk about all things CloudFront or anything else. Just has to be networky. That's it.
Networky.
But we're good to go. So again, thanks folks for showing up. Thanks for all of our usual folks and all the new ones that we've seen. This is recorded. It will be on theroutingloop.net. So give us a little bit of time, a few hours, whatever. If you go to theroutingloop.net, you'll see all of our previous episodes, upcoming episodes, all that fun stuff. And it'll also be on YouTube. Thank you very much and have a good one.
Thanks, Jamie. That was fun.